Okay, so here's the thing. What's the floor function of a plus square root b to the power of n? Is that thing even or odd? So here a and b are integers, and like b is some kind of square free integer most generally, but it may also be some square. We don't care about that. And a minus square root b, this difference is less than 1 in magnitude. So we need to find whether this floor is even or odd. So let us see what we can do. First of all, I can say that a plus square root p to the power of n. Okay, first of all, let's make two cases out of this inequality. So here we can assume first of all that maybe like a is bigger than square root b. So that would make a minus square root b positive and at the same time less than 1. Or you could have square root of b minus a being positive and less than 1 at the same time. Okay, so let's go with the first case first of all. So we can write a plus square root p to the power of n as some integer plus some fractional part obviously. And what else can we do? Well, we can also write a minus square root p to the power of n as some kind of fractional part, because this thing is definitely less than 1. So that thing raised to the nth power, which is like a positive integer, that should also be less than 1, right? So over here this is going to be something like f dash. So here f and f dash are fractional parts, which means they are between 0 and 1, uh, where 0 is included and 1 is not included. Okay, so now what? Maybe we can actually add them up. So if I add them up, I'm gonna get I plus f dash. Okay, that is supposed to be equal to so if you add them up, you can see that you are only going to get the integers, right? So the rationals of the integer stuff, right? So you're going to get like, let us see, a power n plus nc1, and then okay, so I should actually put nc0 over there, and then a power n minus 1 square root of b plus nc2 a power n minus 2 square root of b squared and stuff like that. Okay, and then over here you're going to get nc0 a power n minus nc1 a power n minus 1 square root b positive nc2 a power n minus 2 square root of b squared and so on. So you can see that all the odd terms, right? By odd terms I mean where the r number is like an odd number. So over here the value of r is 1, here the value of r is 1. Those things are actually getting cancelled, which means we will only be left with the even stuff. And the good thing is that because it's the even stuff, we are also going to get the power of square root b as some even number, which means now square root b raised to some even power, that's obviously some integer. So that means that this thing is going to turn out to be some integer, which means that f plus f dash should also be an integer. So now we can use the inequalities. So like f is less than 1 and it's bigger than or equal to 0, and f dash is less than 1 and bigger than or equal to 0. Okay, so oh wait, f dash is actually bigger than 0, right? It's exactly bigger than 0 because it is also like positive, right? Cool. So if I just add these inequalities up, I should get f plus f dash is less than 2 and bigger than 0. So what integer is such that it's bigger than 0 and less than 2 at the same time? Yeah, it's 1. So that should mean I plus 1 is equal to some integer, but wait, not just some integer. You see this plus that, that's going to be like 2 times of whatever thing you got. There's like nc0 a power n plus nc2 a power n minus 2b whatever. So whatever that integer stuff is, just 2 times of that, which means it's like 2 times m, where m is some integer, which means that I is 2m minus 1. Therefore I should be, yeah, I should be odd. Okay, cool. So now what happens if we go with the second option? So like 0 is less than square root b minus a, which is less than 1. Okay, so let's go with that now. So now this thing, a plus square root b to the power of n, I'm going to write pretty much the same stuff. So like a plus square root p power n, that is I plus f. But now instead of writing a minus square root b, I'm going to write square root of b minus a to the power of n, right? That is f dash. And now I'm going to subtract these things. So a plus square root b to the power of n. I should actually write this as square root of b plus a. So square root of b plus a to the power of n minus the square root of b minus a to the power of n, whatever. That is supposed to be I plus f minus f dash. Okay, so now if I subtract this thing, you are going to get the same stuff. You're going to get something like 2 times some integer, right? So over here it's going to be like all the odd stuff. Yeah, so the stuff where r is a odd numbers, like r equals to 1, r equals to 3, r equals to 5, and so on. So that into 2, because you got 2 times of that stuff, so like 2m, that is this thing. So this is an integer, so this thing should also be an integer, which means that f minus f dash, that should be 0. I mean, it's positive, it's less than 2. Wait, what? No, sorry, f minus f dash, it's going to be from -1 to 1, right? So that's why it's 0. So the lowest value is -1, which is actually not really possible because f dash is a positive number, and the biggest value is 1, which is once again not possible because like f dash is a positive number. Yeah, that should make sense. Okay, so that means that this thing should be 0, so this is equal to I. Therefore the floor function over here is some even number, and in the other case it was an odd number. So what we just saw was that if you can get his inequality, then the floor function is going to be an odd number. Okay, and if you get this inequality, you should get an even number, and that's it. That's the whole thing. And also you get these things like f plus f dash equals to 1 over here, and f minus f dash equals to 0 over there, and stuff. And you also get like f dash times I plus f is equal to, oops, is equal to wait, not 1 exactly, it's like a squared minus b, or b minus a squared, depending on what we are talking about, to the power of n, right? But that equation is kind of useless. We didn't even use it in this whatever we did over here. So yeah, that's it. I will see you in the next video.